Hello everyone and welcome to the Maths Lab channel. Today we will see some more examples on vector differentiation, in fact vector identities. Show that curl E bar is equal to del raised to 4 E bar if E bar is solenoidal vector field. If E bar is solenoidal vector field, then we have to show that curl E bar. Have you written it? Curl E bar is equal to del raised to 4 E bar. So here we have to show that if our E bar is irrotational, then 4 times curl is same as del raised to 4. Okay. So we will solve it. First one is E bar is solenoidal. Vector E bar is solenoidal. We know that solenoidal means del dot E bar is equal to 0. A vector field is solenoidal if del dot E bar is 0. So here del dot E bar is equal to 0. This concept we have to use. Now we just take these two curves first. LHS curl E bar. We consider this curl E bar. Two curls we collected. Now curl means del cross. This curl means del cross in bracket del cross E bar. Curl E bar means del cross E bar. Have you understood it? Curl of E bar means del cross E bar. Now we are going to use here A bar cross B bar cross C bar. I hope you have memorized this or studied well to get this one. How to write this one? Yes, we start with A bar dot C bar into B bar minus B bar dot A bar into C bar. Properly, just removing this B bar into multiplying B bar. Again, we start with B bar and C bar multiplied. Okay. I have explained in previous videos. You just see that video and try to understand it. Now apply this. This is my A bar, B bar and C bar. So it is equal to, we can write, yes, A bar, instead of A bar, del. So del dot, leave this del, E bar, del dot E bar into del minus, start with B bar, means this middle del dot, leave this E bar, you will get here del dot del E bar. But del dot E bar is 0. Del dot E bar is 0. So this term is 0 minus del dot del is del square. So del square E bar. So my answer is minus del square E bar. Now I call this as simply F bar. Some notation, temporary notation I use, F bar. Now apply this remaining two curl. So here curl E bar is equal to, but curl of E bar is equal to what? F bar. So here curl F bar, and curl means del cross, again del cross F bar. If you have understood the first step here, curl of E bar, then you can easily write down here del cross F bar. That is curl of F bar. Instead of E bar, you have to write F bar only. So do it yourself. You can get, yes, del, read with me, del dot F bar into this del minus del dot del into F bar. Now E bar is solenoidal, means del dot E bar is 0. So here del dot F bar is also 0 minus del dot del is del square, and here f bar. But what is the value of f bar? Value of f bar is minus del square e bar. Correct? Now del square into del square, it is del raised to 4 e bar. So this is our answer. Hope you have understood it. Now we will take one more example. Here the example is related to irrotational and solenoidal vector field. So the question is, show that f of r into r bar is always irrotational. See the question carefully. Show that f of r into r bar, this product f of r into r bar is always irrotational. Also find f of r if f of r into r bar is solenoidal. If this vector is solenoidal, we have to find f of r. Okay, first we will concentrate on to show f of r into r bar is irrotational, means del cross f of r into r bar. We know that for irrotational we must have cross product equal to 0. Del cross f bar is equal to 0, then f bar is irrotational. Hope you have understood or remember it. Okay. Now we use one simple formula, our second identity, del cross phi u bar. Yes, read with me so that I can get the concept, get the what you have did. Yes, from the previous videos. Yes, del phi cross u bar plus phi into del cross u bar. Now instead of phi, write down f of r, and u bar, write down r bar. So what I get here, del of f of r cross r bar plus f of r as it is del cross r bar. But del cross r bar is 0. Del cross r bar is 0. And del of f of r is f dash of r into r bar upon r. Everybody knows it, right? If you have learned the previous videos, then definitely you know this concept. So here f dash of r into r bar upon r cross r bar as it is, and this is 0 because del cross r bar is 0. R bar, cross product of same vector is also 0. So this term is 0. So del cross f of r into r bar is 0. Therefore, yes, this implies f of r into r bar is irrotational. Okay. So this is our first simple concept. Now to find f of r, if f of r into r bar is solenoidal, that is del dot f of r into r bar is equal to 0. This is assume, we have to assume because it is given that this function is solenoidal. Now I have to find f of r. So again apply dot product theorem, del dot phi u bar. I am not writing here now, directly you can apply del of f of r, yes, dot r bar plus f of r as it is del dot r bar. Correct? Del of f of r bar as it is plus f of r as it is del dot r bar. Now we know that del dot r bar is 3 and del of f of r we know f dash of r into r bar upon r. So here f dash of r into r bar upon r dot r bar plus del dot r bar is 3 f of r is equal to 0. Now r bar dot r bar is r square. Clear this concept here. R bar cross r bar is 0 and r bar dot r bar is r square. So here f dash of r into r square upon r plus 3 f of r is equal to 0. Okay. This implies one r get cancel. R into f dash of r is equal to minus 3 f of r. Now I transfer this f of r to LHS and this r to RHS. Yes, note this step. f dash of r upon f of r is equal to minus 3 upon r. Variables are separated, now integrating. So here integration of f dash of r upon f of r dr is equal to integration minus 3 upon r dr. So what is our integration? Log of or ln of f of r is equal to minus 3 ln of r plus ln c, or you may write log directly, no problem. Okay, so ln of f of r is equal to, using logarithm rule, ln of r raised to minus 3 into c. Cancel both side ln. So f of r is equal to c upon r cube. Check your calculation. We have to stop here. Thank you. Thanks for watching.